Hello. This is an introduction to ocean acidification and how it affects living things. So we've been talking about carbon dioxide being put into the atmosphere by humans, or at least extra carbon dioxide at a faster rate than normal. And that carbon dioxide in the atmosphere, just like any other gas, can dissolve into the ocean. Now, this is a normal thing that's happened since before humans were around. CO2 gets dissolved into the ocean, and that's actually good for lots of marine life because through a process that we don't have to get too involved in, through a process that CO2 some of it can be converted into calcium carbonate for use by these organisms. So these are organisms that have shells or hard parts, hard skeletal parts. A lot of these are at the smaller end of the food chain. And this is normal. Now, since we've changed the pH of the water, we're bringing it down and making it more acidic, this process gets interrupted. There are fewer of these carbonate ions available for calcium carbonate. So fewer of the molecules that these organisms need to make their shells and hard parts. Through a chemical chain reaction, CO2 dissolves into ocean water, is turned into calcium carbonate. Calcium carbonate is used by organisms with shells and hard parts. When oceans become more acidic, the chemical reactions favor making more bicarbonate, which you can see between these two. More bicarbonate is made here, and less calcium carbonate, causing problems for living organisms. Okay. This is a series of photos of this little organism. This is just one example of thousands of examples. These are called pteropods. Teeny tiny little shelled organisms that can be found in the ocean. In more acidic conditions, you can see they go from having a nice shell here to the shell starting to deteriorate because it doesn't have the building blocks that it needs to grow to its full potential. Pteropods are tiny organisms that can be found towards the bottom of the food chain in the ocean. They have very thin protective shells. Less calcium carbonate means the shells and organisms get weak and die more easily. So when we're talking about the bottom of the food chain, we're talking about what everything else will be eating. That energy will rise from the bottom of the food chain up. And then we've got a series of pictures here that show oyster shells. These are 3 different adult oysters grown under 3 different pHs, with the 7.3 being the most acidic and the 7.8 being closer to normal ocean conditions. You can just look at them and see that they're different. This one over here has more of the dark coloration, and it's actually going to be a thicker, heavier shell than these ones over here, which get progressively thinner as you go towards the acidic side. Since ocean acidification affects the larval stage of these creatures, the adult forms exhibit the same weaknesses, which we saw. This image shows a decreasing weight of oyster shells. So the oyster shell that is the highest weight is over here on the right, and the lowest weight over here on the left. Okay, this is just a start. Hope this helps. Thank you.